Hey Chad and Eric, will you please help me with this logarithmic function problem I'm on? I can't figure out how to solve it.
Yeah, no problem, Jillian.
Natural log of the function x equals 8. So to do this, you have to start out by let both sides be exponents of the base e. The equation natural log of function x equals 8 can be rewritten as e to the natural log of x equals e to the 8. Now step 2 is you should know that when you use the base of the exponent and the base of the logarithm are the same, the left side can be written as x. The equation e to the natural log of x equals e to the 8 can be now rewritten as x equals e to the 8. Now, the exact answer and the appropriate answer is x equals 2,980.957. You can check your answer in two ways. You could graph the function natural log of x equals 8 and see where it crosses the x-axis. If you are correct, the graph should cross the x-axis at the answer you derived algebraically. You can also check your answer by substituting the value of x in the initial equation and determine whether the left side equals the right side. For example, if natural log of 2,980.957 equals 8, you are correct. It does, and you are correct. So that's how you solve a logarithmic function and check your answers for accuracy. Any more questions?
Actually, I'd love to know more about logarithmic functions in general. Is there anything important I should know about its family of functions?
Yes, definitely. You should know that logarithmic functions are the inverse of the exponential functions. Any exponential function can be expressed in logarithmic form. All logarithmic functions can be made into exponential functions.
Sweet, that's good to know. Would you show me what the function might look like algebraically?
For sure. So this is how you write it algebraically. If you have a log base 10, you can write it just basically as log x. Now if you have a log base e, you can write it as the natural log, which is just the ln x.
Oh, what about graphically?
I can show you that. So here you have a parent graph of a logarithmic function, and you see a few things that are very distinct. So when you look at the y-axis, you see that the graph does not touch it, which means you have a little bit of an asymptote on the y-axis, which means that your actual equation cannot equal 0, which would mean the y would be 0, so that's off the table. Then you always know you have the point of your base and then comma 1. So your base of your log always goes down there so that you can have a little bit easier of a graph to graph out. And then you also see that there is an asymptote forming somewhere along the x-axis. It's coming across, making sure that the graph is slowly plateauing.
Wow, that looks so cool. Any special formulas or properties that would be useful to know for logarithmic functions?
Well, you should probably know how to move the function if it needs to be. For the function y equals log base b times the quantity of x plus h plus k. The vertical shift, if k is more than 0, it will be up. And if k is less than 0, the shift will be down. Now for horizontal shift, is if h is more than 0, the graph will be shifted to the left. Now if it's less than 0, it will be shifted to the right. Think of it moves the opposite of the sign. You should also know the change of base formula, which will help you solve logarithmic equations that need to be rewritten with a different base. It is very useful for finding logarithms in the calculator.
We can change the base of any logarithm using the following rule. Log base b of a equals log base x of a over log base x of b. When using this property, you can choose to change the log to any base x as long as the base is consistently used on the top and bottom of the fraction.
You seriously can't have any more questions, Jillian. We've told you almost everything we know.
I know. Just one more. I really want to know this function for my business calc class. I want to know where I might see this function in the business setting.
I'll take this one, Eric. In the business setting, a logarithmic function can be used to find compounding interest. Now, in a matter of fact, every time you're working with numbers in terms of 10, you're dealing with logarithmic functions. So that can basically apply to any sort of life.
Thank you guys so much. Mr. Church is going to be so impressed with my knowledge of logarithmic functions. He'll have to give me an A on this next project.
Oh.
Thank you guys so much. It's okay, time out.
E equals 1. Then you can write it as e to the 1 equals e don't know what I'm talking about.
No.